this video, we're going to look at the proof, sort of the fundamental theorem of calculus part 1. I say sort of because it's really just proof by example to show you why it works. Okay, so remember that our fundamental theorem of calculus part 1 looks like this lovely weird function. And what we learned in the last video is that basically the derivative and the integral cancel out and the x drops in. So our final answer is going to be f of x. If this is anything else, so if this is up here as a function, then what happens is that this cancels out. You plug in your function, but you have to tag it by the derivative of that function. Okay, so what I'm going to do is show you why this is the case. Okay, so to do that, I'm going to need a little bit of room. All right, so what we're going to do is we're going to start off with an example here. I'll go a to x, and let's just say, let's choose something simple. Let's just say it's the function 2t dt. So what I'm going to show you is that the derivative of this will just be 2x. Okay. However, definite integrals are areas. So let's just go ahead and say that this equals an area function, because this is going to give me the area of this between a and x. All right. Let's go ahead and integrate it. What's the integral of 2t? T squared. All right, cool. And we're going to plug in x, and we're going to plug in a. Cool. So what I'm going to get is I'm going to get x squared minus a squared. All right. Okay, now remember, in the fundamental theorem of calculus part 1, I'm going to have a d dx right next door. So what I really want to know is, okay, well, what I just found out is that this whole thing equals x squared minus a squared. All right, now I want to take the derivative, right? Because that's what we do in the fundamental theorem of calculus part 1 is we take the derivative. So what happens when I take the derivative of x squared? I get a 2x. Now what do I get when I take the derivative of a squared? Well, you may be tempted to say 2a, but remember this is a number like 1 or 4 or whatever. So this number squared, the derivative is just 0. Okay. So what would have happened if I had just put a d dx out front, canceled, this would have dropped in, and I should have got 2x. There you have it, proof by example. Okay, now, what if it wasn't just an x? What if it was an x cubed, right? Okay, so that one's going to be a little bit harder to prove, but we can still do it. So hold on 1 second while we clear off this board. All right, as you can see, we're going to do the same integral, but now I have an x cubed. So let's see what happens when I get that. So when I integrate, it would be a t squared. Okay. And let's see, x cubed squared. Let's see, that would be x to the 6th minus a squared. All right, cool. Now let's see what happens. So I found out that this whole thing equals x to the 6th minus a squared. All right, cool. Now let's go ahead and take the derivative. So if I were to take the derivative of this now, the derivative of x to the 6th is 6x to the 5th, and the derivative of a squared is still just 0. So I should get 6x to the 5th. Okay, now let's try our shortcut. So if I go back up, put my derivative in, remember I'm supposed to get 6x to the 5th. So these are supposed to cancel out and that x cube's going to drop down. All right, so when that x cubed drops down, I'm going to get 2 times x cubed. Is that what I got? No, but remember I'm not done. When this isn't just an x, you have to do chain rule. So what's the derivative of x cubed? 3x squared. And there you have it. All right, so that is the proof by example of the fundamental theorem of calculus part 1. I hope that helps a little bit. They're at the very, very end of your homework assignment in section 5.3. Good luck.